So before we begin, I'm going to go through move semantics with rule of 5. I'm going to cover those things too. So we used to have rule of 3. So we're going to go through rule of 3 quickly, and then I'm going to demonstrate rule of 5, see what it is. We understand all those good things. And then we have 40 minutes at the end to do our quiz. Okay? All right? So that's that. So if you are not logged into your computers, make sure you're logged in. You could log in and everything. And when the time for the quiz comes, hopefully all the electronic devices will come to the edge of the tables to this direction. Okay? Smartwatches, I don't know. All the stuff comes over here. You lay it over here. Backpacks and stuff off the table. Only you and your computer. And then we'll start the quiz. Okay? We good? All right. So let's say, let me just start this with setting it to, and I'm testing something new, so hopefully the audio for this thing is going to work, because the other one was going off and on. This is the microphone now. Okay? In case you need to talk, this is what we're going to see. All right. So, starting as usual, again, I apologize if I'm sitting. If I stand, the monitor is going to be covered by these ginormous podium. So that's why I'm sitting. I apologize for that. So let's say I want to create, yes. Oh, thank you. Yes, sure, I can. Better? At the end, you can see this, right? All right. So we are going to add a class. Let's say we want to have some kind of a record. Okay, keep track of some kind of a record. So I'm going to create a class for a record. Okay, I'm not going to go through the namespaces and stuff like that, safeguards. It's just, we want to just talk about move semantics and understand how they work. So let's say my record has some data in it. And here, I know that I'm going to use string header file, so I'm going to go over here in here, and I'm going to add C string over there, and using namespace std. Let's go back here. So I have some kind of a data that I want to keep track of. And what I want to do, I want to set the data to whatever I want to set. So I'm going to create a constructor. And I'm going to have a constant character pointer data passed to it. And by default, it's empty. Easy breezy stuff. Then I'm going to say mdata is set to new. What am I doing? Let me just, let me just split the screen in two. Got carried away. Split the screen in two. Put this thing away. Split the screen in two. Little by little, by the way, you are getting feedback from me on your OOP345 assessment thingy that we did. Remember the quiz 0 thingy we called it? And I asked you to write something? Okay, so yeah, you are getting feedback on that. So I'm going to, let's create this one right over there. So I'm going to have record over here, and in here I'm going to say mdata will be set to new character, str len of data plus 1. And I could safeguard it and make sure that data is not null and then do stuff that is needed for that, but we are focusing on move semantics. That's why I'm not doing validations and stuff like that. And then in here I'm going to say str copy into the data, the data that I just got received. Okay, if you have any problems with this dynamic memory allocation stuff, let me know, because if I continue, then well, we'll be in trouble when we get to the latest. We're good down to this point, everyone? We're good? All right. All right. Obviously, right after this, what I do to make sure everything is clean and nice is creating a destructor. And the destructor will delete whatever we have over there. So delete data. Is your usual question, what is wrong with my code? Virtual. You have to always make the destructor virtual. And even if we don't need a destructor, you create a virtual destructor and you set it to default. Remember, any class you are creating in any scenario, if you can type it, there you go. This is what you do even if you don't need a destructor, okay? All right. So we want to display the record, so I'm going to have something like OStream display, OStream reference. Well, I have OStream, I need to have IOStream in here. And because I'm in a header file, I cannot have using. OSTR is set to stdc out. That's my display. And it's a standard display, so I'm just going to come over here and say I need IOStream in here. And it's adding OC out std over here. I don't want to clutter it, so I'll do it this way. And over here, I'm going to simply say if data cout and that, oh, sorry, OSTR and data and return OSTR. Again, standard stuff, and to make this thing printable with cout so I don't have to type stuff over and over, I'll create an OStream reference operator insertion, and I'm going to have std OStream reference OSTR, and in here I'm going to have a const record reference R. And right off the bat, I noticed that I made my display wrong. It's supposed to be const because it's not changing, so it has to be const. I'll set it like that. Then I'll create this one too, which is as easy as return r.display and done and done. And I'll pass the OSTR to it. Save. Are we good with this? Simple, straightforward, out of the bat. So this is beginning of dynamic memory allocation in OOP345. So we did it like this, and we were happy, and life is beautiful, everything's good. Why is this thing giving me that? Let me compile, see if I have any boo-boos anywhere. Compile. str copy unsafe. Ah, shoot. Okay. Output. Where is it? Copy. Define this, and now I can compile. Control F7 compiles. And we're good. Okay, so it's okay. All right, and to test it and make sure everything's okay, I'm going to create a record. Oh, include record, of course. And I'm going to say record R OOP345NEE, and I'm going to say C out R and run it, make sure everything is good. And 3 years later, it runs and everything's good. Okay, now, rule of 3. Rule of 3 says when I want to move this thing around, because it has resources outside of its scope, only the content of the class will be copied, not the dynamic memory that are outside. Therefore, I need to cover the copy assignment and copy constructor. That's rule number. So what I do is simple. I'll go through those. So copy constructor says I need to have a constant record reference other. So the one that I want to copy. So that's going to be my copy constructor. And the next one is going to be the copy assignment, which returns a record reference operator equal, and it receives a constant record reference other, and that's going to be my copy assignment. Are we good? All right. So when copying is happening over here, what is simply done is I just copy the other guy's stuff as we have over here. So I'm going to say mdata will be essentially equal to new character strlen of others mdata plus 1, and I'll copy everything into mdata from other.mdata. You okay with this? All right. For copy assignment, I know when you're doing in a test, you call the copy assignment in here because you want to be fast. But in here, I'm going to do them both. Copy assignment, first I have to make sure that the person using us is not nuts. So I'm going to say if the address of me is not equal to the address of the other, then do the copying. Otherwise, just return me, and I'm done, right? You're okay? And the copying concept is exactly the same thing as the other, with one difference. The difference is that because it's an assignment operator, it means the object that is being assigned already exists. Because it already exists, I have to wipe its memory off first. Otherwise, I'm going to have memory leak. And that's what we do by saying delete mdata. And now I have copy construction and all the good stuff. Are we good? So in here, I can actually have something like void print record R. And I'm going to have record J or S R C out S. Okay. So if I actually call over here print and I pass R over here, we know that when R is called, by definition, when we said whenever you have a function call, this is what happens. So essentially print is called and record R is there is equal to the mains R. R from main. Let me change the names. I have two R's, it's going to be, so this is going to be T, and in here I'm going to print so I'm going to have T is set to R, okay? And we know assignment at the moment of creation means copy construction. Are we okay with that? Okay. That's the mistake I made to demonstrate assignment at line 6. And I didn't want to reveal it and ask you what is it called, and you make a mistake, and I'll say, no, you made a mistake. Well, because I did the function called demonstration, now I know I made a mistake over there. Assignment at the moment of creation is a copy constructor. So because of that, this is not going to call assignment, but this is, right? So remember, assignment at the moment of creation is just copy construction. Now, if I run this program, two things are going to happen. We can walk through it, but I don't want to waste your time. You know what it is, and it's going to say printing this and that. And what we can do over here, I can actually write messages over here to see if they're going to get printed or not. So in here I'm going to say clog, and I'm going to say copied. Copied other, right? Clog is cout system, okay? It's just, it prints a log. The good thing is that I can disable it if I want to, not to show anything. So I can disable the things off and on, the messages. And in here, I can say, in here, clog, assigned, so I can say over here clog assigned assign this and in here I'm going to say clog 2, and I'm going to show what I did. I can actually print this again because now it's copied. I could have said other, but I'm not going to do that. Okay? Now if I run this program, it's going to actually go through some messages. So it's going to say copy this one, then assign blank to that one, then printing this one. Okay? So when we look at the main, now we can actually see what happened. When we are looking at main, it says copied OOP345NEE. That's when R is passed by value to T. So that message comes from give me a second. I don't know whose idea was to, yeah. Let's do this. All right. So copy T is a copy. That's where this message happened. When it comes to line 7, that's when you see assign blank because S was blank. Okay? And then to that one. If I change this to, for example, S in print. Now if I rerun the program, you will see that S in print will be assigned to OOP345NEE. Okay? And you know that if you want to disable that, all you need to do is to say clog dot set, I think, set f to iOS fail bit. Was it the one? Now if I run it, it shouldn't print it. Oh, it's still printing it. I forgot what set. Set status? Oh, set state. Okay. Set state. There we go. Now it's not going to get printed. So I can put the clog into an error state, and therefore messages are not printed. Or I can do like this and run it, and messages will be printed. Any questions about the end of OOP345 in rule of 3? So this is essentially rule of 3. Rule of 3 says any object that has resources outside of its scope needs to handle the copy assignment, the copy construction, and take care of its destruction. These are rule of 3. Are we good? All right. Now, rule of 5 is me giving you coffee. So what happens is that, actually I had something in here. There we go. So the thing is that if I wanted to give, actually it's water, not coffee, but let's say it's coffee. If I want to give coffee to Scott. If I want to give, oh, so Scott is you. Hello, Scott. All right. That's the marvel of internet. You just look at the names. So if I want to give coffee to Scott, Scott already has a coffee cup. Okay? It doesn't make sense for him to go to Starbucks, buy one thing exactly like this, so I can, and then see how I brewed my coffee, then brew the exact same coffee that I have in his if he wants this. That's crazy. That's essentially what you do when you are copying. Any copy constructor that is being called, you are first building the cup, then you are brewing the coffee exactly like the other one had, identical, and says, now I have what you have. But move copying means, moving, means he gets the cup, you can get the cup, and I'll bring the coffee, and I just pour my coffee into his. And I'm done. Now I'm going to have an empty cup, and he's going to have a cup full of coffee. Therefore, all the process of brewing coffee is down the drain. Much faster, right? Much quicker way to get coffee. Okay? That's what we call moving. Which means when you don't want the data of the original, when you don't, sorry about the silly thing, but that's, when you don't want the data that you have in your original object, then why do you even bother copy? Why don't you just give the data to the other person? Okay? I'll give you an example. Let's say I have a function that reads the sensor data of all the temperatures around the ocean per day every hour for 3 years, and I want to load them all. So there is this function that receives it and puts it in a class called sensor data. It copies everything into here. And then it wants to return it out to a function to receive. If you return by value, what happens? Copy construction. If you don't remember it from OOP345, please know it now. When you return something by value, copy construction happens. How? It's like this. So if I have this print of mine, return at the record that it's printing, return S, okay? If I do that, then I have over here R is set to, or whatever, record ret is set to print, print R. I'm going to put this one over here. When I do something like this, what happens to that S? So think about it for a second. What is the scope of S? Get the microphone. What is the scope of S? Where is S defined? In print. That's all you need to say, and pass the microphone. Okay, so it's just in print, correct? Now, my question from your name? Lachlan. My question is, when you are returning the print, S is being returned, right? To where? S is print to where? Which function is receiving print's value? Very simple question, actually.
Line 16.
Yeah, but where is line 16? It's inside which function?
Oh, in main.
In main, thank you. It's very obvious. These are just obvious questions, okay? So print is returning S. So print is returning S into main, correct? My question from everyone is that, how is that possible? Isn't S defined inside print? Isn't by definition when print is over, S is destroyed? If S is destroyed when print is called, then how can it return it out? Think about it for a second. That's a definition we learned from C. When you have a variable inside the function, when the function call is over, the variable dies, right? So it returns the S, fine, but as soon as the function call is over, S dies, so nothing's going to go to ret. You know how the compiler fixes that? Anything that is returned by value, a temporary nameless object at the moment of return is created. So a record that you don't see at line 9, a nameless record is created. S will be copied into it, and then the value will be carried out by that nameless. Then that nameless, because ret is assigned to it, that nameless will again get copied into ret. S is dead already, and then that nameless dies. See how many objects are getting created just for one return statement? We can fix that. Instead of doing all this, I'm going to say, hey, don't copy the S that you are returning in me. Just move it out. We're going to learn soon how. But it was just an example, okay? Anyways, so how do we actually and the funny thing is that even when you don't receive anything, just take a look at this. I'm going to run this. Actually, never mind. So now, what do I want to do? Okay, now I want to see how can I actually write a code that moves things out. Last time we talked about moving, and we created something like this. How can I file, new file, C++ file. Last time we talked about moving, and we said you can actually detect moving by, okay, I put the wrong one. What did we do last time? We did something. Let me just go to the previous sessions. LVAL and RVAL. I think it's one of these. Yeah. So take a look at this. You see this? For this string thingy over here that we had 2 ampersands. So we said this is an RVAL, a reference to an RVAL. And when we do this, it actually means that move the object over here and don't copy it. So detection for a nameless object, anything that is an RVAL can be detected with 2 ampersands. We said that if I say, take a look at that code, the code that I have written, I have it with the print reference and I'm printing the L value. When I actually have a name, it's passed by reference, so automatically line number 4 is called. But when I put something over there that doesn't have an L value, it's an R value, which means essentially it's pure data. It doesn't have any location in memory. It doesn't have any variable tied to it. The compiler can detect it, and it will be passed by the R value reference. We're going to use that feature for our move semantic, which means I'm going to say record. So if I want to copy, but I want to pass the data instead of copying the data, what I can do is to say, first of all, you will see that I should not make this thing a constant. And I'll tell you why later. So unlike the other one, it's not constant. I'm going to say record, and I'm going to put like that, and I'm going to say other. Now, to save time, what I'm going to do is this. Now, think about it for a second. I want your attention, please, for a second. The object that is going to be moved, it has a data that its pointer is pointing to it, right? So it's essentially this. So when I am copying something, this is what I have. This is my class. This is its data. So what I do when I actually want to make something new, what I do is, I lost my mouse. There we go. So what I do is this. I have the other pointer. First, I will measure to see what is the size over here. I will create the exact same size. Then I move all the data from the old one to the new one. Then I'll make this one point to that one. And therefore, everything is copied. Are we OK with this? Now, this time, I don't want in the other pointer to copy everything. I want to take ownership of the other one. So instead of copying the whole data around, all I need to do is to copy where this thing is pointing over there. And because of that, let's actually change the color. So I'm going to copy the address in here. And because of that fact, my pointer will point to the same place, correct? Then what I do, I simply set the other one to null. So no copying. I'm simply saying my pointer will point where the other pointer is pointing. Now make the other pointer null. So what happens is that I'll take ownership, the other one has nothing. I empty my coffee in that cup is full, mine is now empty. Are we okay with this? And that's exactly what we're going to do in the code in here. So what I'm going to do is this. I'm going to say m data of mine, the address that I have, will be equal to others m data. So now we are both pointing to the same place. The very thing we wanted to avoid, that's why we created a copy constructor. But the difference is that now that I take ownership, so I'm going to say over here, taking ownership of others' data, and I simply say, other, you have nothing. Okay? Now in here I'm going to say moved. I can't say other, because other just lost the data. And I'm going to say move this data. As simple as that. Okay? So you see the code is much simpler because all you are doing is taking ownership of the other thing's data. Okay? Now, the next thing I'm going to do in here is this. I'm going to say for the assignment. So it's essentially the exact same thing, but the difference is that this is not constant, and that's an R-value reference. So we create the exact same thing. The code is almost identical to the other one, which means first you have to check, make sure I am not the other. And then after that, you do the exact, let me put this thing up over here, right where the other one was. So then what you do over here is saying, what do I say? I say the exact same thing. Like that. So I literally take over the data of the other one with the exception that I have to delete my own first. Delete out data, take ownership of the other one, and set the other one to nothing. And then return this. So by doing something like this, now I can actually move data from one place to another, which means in here I can actually create record, something like R. In here I'm going to say S, and in here I'm going to say some data. Now I can say S is equal to move R. So what happens is that, and then after this I'm going to say C out. Oh, in my display I think I did that. So in here I'm going to say C out R. And then, oh, I already have that one up there. I'll remove that. And in here I'm going to say S. I don't need the print for now. Oh, actually for this print I'll demonstrate. I'll put the print at the bottom. So now I'm going to do this. And let's put a message in there too. So clog move assigned this. In here, I'm going to say log. This is move assign to. Okay, so now when I run the program, stop. Wrong, don't look at it, don't look at it. This is supposed to be S, I'm printing R all over the place. I don't know why it's giving me that. Anyways, oh, okay, sure. There you go. As you see over here, R had OOP345NEE, S had some data. After moving is done, R lost all its data because its data is now moved to S. As simple as that. Okay? So, and this can be done like for that print thingy that we have. If I do not want to do anything with S, the proper way of printing is to move S to print it in print. So by doing something like this, actually moves it, it doesn't copy it anymore. Now, T over there, it's got, so essentially this happens. Okay, so S, this is the last statement, S. Now, right before printing, it moves the S, that is OOP-NEE, into T. Now T is doing all this stuff and printing over there. So T will get the data of S and it will not copy it. You will see that this is going to be hundreds of times faster whenever you are passing stuff around with large data. Okay? And that's it. That's move semantics. Questions? Questions? Suggestions? Yes. Pardon me? Move function is not move function, it's STD, it's move. It's, it literally tells the compiler that this is supposed to be treated as an R value. So see, if I do this, I don't need to write move. Take a look. It's not going to give me an error, right? Well, what happens over here in the second one, it's going to create a temporary nameless record out of that data. Because it's temporary nameless, all temporary nameless objects by default are moved. They are never copied. As a matter of fact, the compiler actually lately optimizes some of that too. Even before you do the move assignment thingy, it just doesn't listen to you and, and does the move by itself automatically. So if you did the C++ programming 15 years ago, anything you passed by value would be copied. Now, sometimes when the compiler is sure, it's just going to move it out. Yes?
So that's why it doesn't infinitely loop in on itself, value that keeps getting returned and made a copy of?
Yeah, exactly. Yeah. Otherwise, exactly what you said would have happened. Okay? Are we okay? That's it? All right. Now, get 5 minutes break, and then we're going to do the quiz. I'm going to prepare the stuff, and we're going to do the quiz. So if you no question, I'm going to stop the recording. and hope for the best that it actually recorded. Are we good? All right.